Hello. Today we're going to explore how to graph parametric equations using different numbers and how you can quickly see the results of changing different constants, and also using sliders. So there are two places in Classpad.net where you can enter parametric equations, and that is in the graphing right here or in the geometry. So I am going to show you both, but I'm just going to go into graphing first. So when you pull up graphing, down here is where you enter your functions. And when you get that, you get the equation sticky, and here's your soft template that pops up. And right next to the X is this parametric template. So when you click it, it automatically sets everything up for you to put in a parametric. So let's just do a really basic one, the parametric equation for a circle. So if I go into math, I can get my trig functions here, and so I can enter the t using my computer, or I can actually use the ABC down here if I need to, but we're going to use our computer. And so let's go get our cosine and t, and now when I hit execute, I'm going to see a circle. So it's a basic circle where the coefficient here is 1. So one thing you can do very quickly is change the numbers just to see the impact it has. So let's say I put, instead of a 1, a different number here. Let's put a number larger. What happens to my circle? And so that obviously horizontally changes this into an ellipse. And what if I did the same thing to the y at t? Did the same thing. Let's just make it be the same constant. I'm going to now have a circle that is larger, has a radius of 3. So this determines the radius of my circle, if they're both the same, or how elongated an ellipse I have. So that's one interesting thing I can do with this. So let's get rid of these numbers and now focus on, what if I add a constant coefficient here? So let's do that and hit execute. And so notice that now I get some interesting shapes here. And let's see what happens if I added it to the cosine or the y value. What happens here? So again, it's horizontal versus vertical, which is very interesting. What if I did them both? So let's do 1 at 2 and 1 at 3. What's going to happen to my shape? And so I get interesting designs here. You can really kind of explore. It sort of determines how many loops I have, if we think about it that way. What if, and so you can do these quick explorations simply by replacing numbers. What if I added a number here to the t value? Whoops, let's choose add. What's going to happen? And it tilts my ellipse, right? And so I could play around with things like that. What if I added another, I don't know, let's make it be, and see what happens here. So lots of different things you can quickly explore and play around with. I'm going to get rid of this and talk about ways that you can explore this with sliders as well. Let's say I want to just explore what happens if I put a coefficient in front of this. So instead of a number, I'm going to use a variable, and it can be any variable you want. And I'm going to need to use my time symbol here. And let's use b here. When I hit execute, because I didn't use values, I used variables. I didn't use numbers, I used variables. These now will change. And so I can now quickly explore what happens as I change the coefficient, a. Instead of just plugging in random numbers, I can actually kind of explore by looking at them. So students can say, oh, well, that's really interesting. It is making it be an ellipse along the horizontal. Let's get it back to 1, and if we do the same thing, we can make the conjecture that it's doing it vertically. So they can start exploring that way. And then we could add in, say, another constant. Let's put a c here. And again, it doesn't matter what variables I use. I'm just doing them alphabetically at this point. But when I hit enter now, I have more coefficients. So let's see what happens as I change these. And it's just changing the loops that I have. So let's make the circle bigger. Let's make them still be a circle. So to be a circle, we've already learned that if we change them the same, so they're both at 4 now, I'm going to just have a circle with a radius of 4. But now I'm exploring what's happening with my C and my D as I change them, and I'm getting some interesting shapes here. So students could really explore and do some interesting art. let's set this back to, let's make it be 8 and 5. So that's a really interesting shape. So now I can just do lots of exploration. So very easy to enter a parametric, and I can even enter several on top of each other. So I could enter another one, this time in a different color, and here's my parametric. And so let's do some exploration here. So let's still use the same coefficients, or actually no, let's just, so what do we know? That's going to make a circle. And now we're going to subtract. So you can really explore different things with students. And let's make this be 2 sine t minus sine. And so now I have a shape within, and so I could add, now let's say I want to do a different one. So I could really kind of do things on top of each other. What if I just explored, again, parametric here, if I did some cubing? So let's see what happens if I, cube this. So there's lots of things you can explore. Very quickly. And so notice that I have this in here, so maybe I want that to be a little bigger. So I already know that this is going to make it bigger. And there is bigger. So you can do some interesting combinations of parametrics and get some very nice designs. So that's basically all there is to entering parametrics. You can play around with the t values, the t range, how you combine things using sliders to control. Maybe we want to have a smaller, make it more elliptical. Maybe we want this to be less loops. So lots of things you can do to explore. So the other place where you can enter parametric equations is in the geometry sticky. So if we pull up a geometry sticky, it behaves the same way except where you are finding them. And the reason you might want to do it in the geometry is maybe you want to do a parametric in conjunction with some other geometric shapes. So to get to the parametric, you are going to go to this tool right here. It's called the polygon tool, but it's actually got several tools. So you notice that's where the conics live. So that's why it makes sense where this is where also you would enter your functions. So when you pull up the function, it's the exact same soft template. You pull in this grid right here, and you enter a function, the same thing here that we would do before. Let's do 3 sine 2t, and let's see what we end up with here. 2 cosine 2t. And so the difference being, so when you're in the graphing and you enter a parametric, the equation is obviously in the equation sticky, and if you were to click on any one of these functions, you'd see it also appear in the graph, as well as the key points of that specific function. But if you want to do it in the geometry, what happens is this equation also automatically appears in the geometry sticky itself as sort of showing you. It doesn't show you the key points, so that's one thing that makes it different from doing it in the graphing. This is just a geometric object, and so it's not going to show you the key points because it's not on the graphing functionality. You could add geometric shapes to it. So for example, I could say add a polygon this time and put a polygon within that. And so use my parametric function as a basis for other things. So it sort of just depends what you want to do with your functions. But you can do parametric functions both in the geometry sticky and in the graphing sticky. And just how they behave is slightly different. In the graphing, you're going to be able to find key points. You can also do sliders in geometry as well. So all of that remains the same. If I were to change this to, let's use a letter we haven't used yet, a variable we haven't used yet. Oops. Oh, we don't want to use T. R. it'll create sliders as well, except it doesn't like the R slider because that actually stands for something. So let's actually use, I don't know, I'm trying to use one I haven't used yet. E. No, E stands F. Let's use F. There we go. So it'll do sliders just as it did up here. So a lot of it is exactly the same. The difference being in geometry, you can actually draw and construct geometric objects on top of your parametric equation. And in graphing, you have to actually just graph them. And I just went a little crazy here and got that out of there. And you get the equation right on the geometry sticky. There is ways to hide that. If you don't want that to show up, you can hide the measurement so that it's not there and you can explore it. But it just depends what you want to do with your parametric, but it's really fun to explore parametric equations because it's so easy to graph them, and then you can use sliders to kind of explore what happens and how do you create different shapes and different images.